here we are with 3.4. So we're still looking at video number 7. This is the last part of it, factoring polynomials. Factoring is really, to me, like unmultiplying. So usually you distribute, right? If you're multiplying some kind of something by something else. This is like undistributing. Don't know if that makes sense, but when we do a couple examples, hopefully you will understand. So I'm looking at, let's see here. I'm looking at this example right here where you have two terms that share a common factor. They both have an x. And so you can rewrite this pulling the x out in front, and then this is what you would get. You're basically rewriting this. It's an equivalent statement, but you're undistributing. Maybe that makes sense, maybe it doesn't. So we're going to first start by doing what we call factoring by grouping. So what we have here are two things minus another two things. These things have something in common. They have a factor in common, which is 2a plus 5b. Just like these two up here had an x in common. So I can actually take that 2a plus 5b out and put it in the front and then rewrite this. Basically, I have to multiply 2a plus 5b by 3a to get that first term plus a minus sign. Then you're multiplying that 2a plus 5b by negative 7b. We just unmultiplied it. So even though I just did that with you, you can kind of see down here a little bit of a breakdown in the notes showing the same thing. Let's look at another example. I have two terms. They have a common factor. It's x minus 5. So I can pull my x minus 5 out front, open a set of parentheses. For this first term, I have to multiply x minus 5 by y. For the second term, you have to multiply x minus 5 by 2. Now this is factored. It's factored form. If you ever think, I don't know if I did it right or not, you can remultiply it out and see if it's equal. But for the most part, people usually get this pretty good. Go ahead and try the second one here, this example, and then come back and see if you got the same thing I got. I'm pulling out x plus 3y. In my second set of parentheses, I should have x squared minus 3. Factoring by grouping. Now, these questions actually told you to factor by grouping. They even set everything up beautifully. But what if something happens like, we have something like this one here where they want us to factor by grouping, but we don't have anything in parentheses. What I'm going to do is I'm actually going to take these first two terms and factor out what they have in common. They both have a 3. 3 goes into 3 and 3 goes into 15. And they both have at least two x's, so I can pull out an x squared. In my parentheses, I know that I would have to multiply this by x to get the original first term. And I would have to multiply this by 5 to get the original second term. Now I'm going to do this again, but I'm going to do it with the second two, or the last two terms. They look like, what they have in common is a 2. Open my parentheses, pull out a 2. 2 times x gives me 2x, and 2 times 5 gives me 10. Now I have this so I can factor by grouping. And notice that, whoa, lo and behold, they both have matching factors that I can pull out the x plus 5. Inside my parentheses is the 3x squared plus 2. Those were what was in front. Amazing. Let's look at this next one. Looks like it's going to be tricky. All right, I'm looking at my first two terms again, 7xy and 49x. I know that 7 goes into 7 and 7 goes into 49, and I know they both have an x, so I can rewrite this, pulling out the 7x. I would have to put a y here, so it would be 7xy minus 7. That's the equivalent way to write it. Now, because I know what the end game is going to look like, I'm actually just going to write over here y minus 7. And then I'm going to make sure I put up front whatever it is that I need to put out front to make it so that this is adds up to being 5y minus 35. I know if I put a 5 out here and I distribute it, I will end up getting 5y minus 35. The common factor is y minus 7. And when I rewrite this, factoring inside is 7x plus 5. This is the page where you are going to do some examples. Go ahead and pause. I want you to do the top two and the middle two. You can go ahead and try the ones down here, but I'm going to actually stop you before you get there and go through them with you. Once you have these completed, I want you to unpause the video and then look at my answers to see if we have something that matches. Pause the video now. And here are the answers. The first one, x minus 8 times 5x plus 2. The second one, z minus 5 times 3z minus 1. The third one, after doing some factoring, x minus 4 times 2x plus 7. The last one, again, after doing some factoring, 3a plus 4b times 2a plus 5. Now let's do the first example on the bottom. We're going to factor by grouping. These first two terms, if I were to look for a common factor, it looks like 3x would be what I would be using. So inside my parentheses is a 4x minus 3. Knowing that I need a 4x minus 3 in order for those to match back here, I'm going to fill in the outside. I know I would need a negative 5 to multiply these to get a negative 20. I'm just going to make sure negative 5 times negative 3 is positive 15. There we go. So now I can pull out the 4x minus 3 and then have 3x minus 5. Fun times. Last example, I'm going to look at this first one. I'm pulling out a 4m. So I have 2m plus 5n at the end. If I were to distribute these, it would bring me back. So I know I'm looking for a 2m plus 5n back here. If I were to multiply negative 7 times 2m, that would give me this, and negative 7 times 5n would give me this. So now I have this in the proper format to be able to factor it by grouping. So let's talk a little bit more about factoring three-term polynomials, but we're not going to do it by grouping, so I'm going to go ahead and erase that. I'm going to do this using the AC method, which is what I had when I was in high school, which is basically a whole lot of trial and error. Sorry. So this is how it's going to work. The fact that you're asking to be to recognize A and C is referring to these three numbers. A is the leading coefficient, the one in front. B is the middle coefficient. C is the constant. What you need to do if you're going to factor something like this is the first thing is you need to multiply A, which is 2, by C, which is 32. 2 times 32 is 64. I need to really zoom in, or else it's going to look awful. 64. Now I need to list all of the factored pairs of 64. The things you can multiply, I always start with 1, like 1 times 64. 2 times 32. 3 doesn't go into 64 beautifully, but 4 does. 4 times 16. 5 doesn't. 6 doesn't. 7 doesn't. 8 does. 8 times 8. And I think that's all of the factored pairs of 64. Now, what I need to do is I need to figure out what set here can I combine to get negative 16. I can combine it by adding or subtracting. 1 and 64 cannot be combined in any way to give me negative 16. Same thing with 2 and 32 and 4 and 16. I can deal with 8 and 8 because negative 8 plus negative 8 would give me negative 16. Knowing now how to break this down, I'm going to rewrite this 2y squared minus 16y plus 32, but instead of writing the negative 16y, I'm going to do -8 and then -8 again. I'm just rewriting the -16 as something that has, it's equivalent. So now I can complete this factoring. The beginning two terms, I can factor out a 2y. In the middle is y minus 4. I know now I need a y minus 4 back here. So if I were to multiply them by -8, so -8, that would give me -8y plus 32. So y minus 4 gets pulled out and 2y minus 8 stays in. Pretty cool. Let's look at the next example. If you were doing the A times C method, again, there's a 1 in the A spot, so 1 times 25 is 25. Factored pairs of 25, there's not many of them, there's only 2. I need to be able to find 2 numbers I can combine to get -10. Won't work here, but I can manipulate and say -5 combined with -5 would give me -10. So now I can rewrite this as x squared minus 5x minus 5x plus 25. I can factor out an x. I can factor out, I know this needs to say x minus 5. So if I put a -5 out here, that will make it work. X minus 5, x minus 5. There's my factored version. All of the steps from everything that we were doing has been listed here. Again, remember, don't be afraid to manipulate and create common factors to pull out. And so again, this is what we were doing every time. We're kind of doing some manipulating to try to make things work in our favor, and it's okay to try different things. I want you to take a moment and do this example to the best of your ability using the AC method, and pause, come back in a moment, and I will go over it with you. Okay, A times C is -60. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7, 8, 9, and that's it. Okay, and because this is negative, I know that one of these, whatever one of these sets I use, one of the numbers has to be negative, one has to be positive for them to multiply to give -60. I'm looking for the pair that can add up to -7. That looks like it's going to be this pair here. If I have a -12 and a +5, those would add up to -7 and multiply to give me -60. So I'm going to split up this middle part. Instead of writing -7a, I'm going to say -12a plus 5a minus 10. Notice that I purposefully put the 12a in the front and the 5a second, and that's because I know 6 and 12 can work together and 5 and 10 can work together pretty well. I'm pulling out a 6a. That gives me a minus 2. I'm pulling out, well, let me see what I'm going to pull out. I want to have a minus 2 here, so I'm going to pull out a +5. Now I'll have 5a. And then I am going to rewrite this. I pull out the a minus 2 and then the 6a plus 5. There is my factored version using the AC method. 3 FYIs, probably pretty important. The first one, if you find yourself looking at something like this, see if there is a greatest common factor you can factor out before factoring by grouping. This one, it looks like I don't see one that had, there is no GCF for this one, but if you see something that seems really, really big, sometimes you can factor out a number from all 3 terms, and it makes your life a little easier. Number 2, sometimes a polynomial cannot be factored by grouping because the factors are decimals, and in this case we would have to find the factors using what we call the quadratic formula or by graphing, and we haven't done that yet, but it is a thing that is possible. Number 3, sometimes polynomials cannot be factored further than their original state, and we describe this by saying that the polynomial is prime. That's how we would say that. Okay, let's go to the next page. Factor the following using trial and error. This is more like what I was talking about in the last page, and I realized my notes were not going there yet. If you have a trinomial that has a leading coefficient of 1, then you can literally say to yourself, what two numbers can I add to get 7, but multiply to get 6? 6 and 1. 6 times 1 is 6. 6 plus 1 is 7. 6 and 1. Crazy. What two numbers can I add to get negative 4, but multiply to get negative 12? 12 and 1? Nope. 3 and 4? Nope. 6 and 2? Ooh. I know that if I have negative 6 and positive 2, those add to give me negative 4x and multiply to give me negative 12. So I can write x minus 6, x plus 2. This one here, I would never suggest trying to do trial and error for something that has a leading coefficient of 6. I only do that if I have a leading coefficient of 1 because I don't want to waste my time. So if I was going to do one like this, again, I would multiply the 6 times negative 35, which is 210, negative 210. And I'm looking for two factors that when I combine them, they give me x. 1 times 210, 2 times 105, 3 times 70, 4, nope, 5, yes, 5 times 42, 6, 7 times 30, 8, 9, 10 times 21, 11, 12, let's see here, 13, 14, let me look in Desmos. So in Desmos, what I did is I just tried a few different 210 divided by this, that, the other thing. I did come up with 15 times 14. 15 and negative 14 would add to give me 1. And it would multiply to give me negative 210. So I'm going to rewrite this as 6x squared minus 14x plus 15x minus 35. I can factor out a 2x. That will give me 3x minus 7. I know I want a 3x minus 7 back here. And the only way to do that is to multiply that by positive 5. So I have 2x plus 5 and 3x minus 7 as my two factors. The last one here, two numbers you can add to get negative 11, but multiply to get 28 is negative 7 and negative 4. X minus 7, x minus 4. Those are the factors. Determine whether the given polynomial is prime. Right here, they don't have a common factor. There's nothing I can factor out, so this would be prime. Here, are there two numbers you can add to get 2 and multiply to get 20? 1 times 10, oops, sorry, not 1 times 10, 1 times 20, 20, 2 times 10, 4 times 5, nope, doesn't look like I have two that I can manipulate to make that, so we're going to say prime. Here's one of those examples I was saying, like sometimes you can see right off the bat that they have a common factor. I'm going to pull out a 3. So I can rewrite this as 2m squared plus 3m minus 10. This 3 in parentheses is going to come along for the ride the whole time, but I know that if I want to factor the inside of this, I have to multiply 2 times negative 10, which gives me negative 20, and then find if there are two numbers I can multiply to get negative 20 that I can add to get 3. And it looks like that's not a thing. This would be as factored as it goes. So we would say this is not prime from the very beginning until there is a trinomial in the parentheses, and then it is prime. So we were able to factor out a GCF, so this is not technically prime, but what we had inside of here was prime. So if you had this on a homework question, you would say it's not prime because you could factor out a 3. But if it just started off like this, then you would say, yes, it's prime. I couldn't do anything. Okay. We're on page 64. I'm still looking at some other examples of factoring. We're now getting into the special cases. One of the special cases is called the difference of two squares. This happens when you have a thing squared minus a thing squared. For instance, if you have x squared minus 64, I can rewrite this as something squared minus something squared. X squared is actually the variable x squared, and 64 is 8 squared. If you can do this with a minus sign in the middle, then you can factor this with two sets of parentheses. One has a plus, one has a minus, and x gets to go in the fronts, and 8 gets to go in the rears. X plus 8, x minus 8. It only works if you have something squared minus something squared. Let's just try one more. Let's say 4x squared minus 100. Something squared minus something squared. I square 2x to get 4x squared, and I square 10 to get 100. So my parentheses get opened. 2x plus 10, 2x minus 10. There are my factors. Now let's take a look at some examples. I'm going to let you go ahead and do A, B, C, and D. Should have no problem. And then come back and compare your answers to me. Pause. Come back. Just a few minutes. Work on it nicely. Okay, so for the first one, x plus 3, x minus 3. You square x squared, you square 3 to get 9. The next one, 2a plus 5, 2a minus 5. The next one is not the difference of two squares. It's the sum of two squares. So this is prime. It only works if there's a minus sign in there. The last one, 3m plus 4n, 3m minus 4n. Okay, so we have some examples on this very last page. Go ahead and take a minute and do these three and then come back and check your answers with me. Go ahead and pause the video now. Okay, so I ran out of room. I didn't zoom in very good. X plus 6, x minus 6, that's A. 4a plus 9b, 4a minus 9b, that is B. C is prime. It's the sum of two squares, not the difference of two squares. Looking at A, we have to ask ourselves, can we write this as something squared minus something squared? 81 is 9 squared. X to the fourth is really x squared squared, because we have that power to a power rule. So if I were to write this out, I'd have x squared plus 9, x squared minus 9. The thing is, I still have the difference of two squares right here. I have something squared minus something squared. So I actually could break this down even further as x plus 3, x minus 3. Be careful. Let's look at this next one. Something squared minus something squared. Well, I'm looking at this and I know that 3 and 192 are not a perfect square. But I do know that I could rewrite this as 3 times x squared minus 64y, not squared, 6 to the 6th to the 6th. So now I can go ahead inside my parentheses and try to write this as something squared minus something squared. And it might work. For instance, if I had x cubed, 3 times 2 is 6, and I had 8y cubed, no way, 3, x cubed plus 8y cubed, x cubed minus 8y cubed. Holy Hannah. That one's really, really tough. Go ahead and take a minute, try this very last example, come back, see if you got what I got. Something squared minus something squared. T cubed squared is t to the 6th, and 8 squared is 64. So I have t cubed plus 8 and t cubed minus 8.